Hi, and welcome back to our channel. Today we will talk about black holes and what makes them so fascinating. Without any further ado, here's 10 fascinating facts about black holes. Imagine this. Millions of black holes lurking within our very own galaxy, the Milky Way. These invisible behemoths, remnants of collapsed stars, are scattered throughout the cosmos. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They form when massive stars exhaust their nuclear fuel and collapse under their own gravity. Imagine squeezing the entire mass of the Earth into something the size of a marble. These cosmic monsters are notoriously difficult to detect. Astronomers infer their presence by observing their effects on surrounding matter. If a black hole passes close to a star, its gravity can rip the star apart, creating a swirling disk of gas and dust. While millions of black holes might seem unsettling, space is vast, and the chances of encountering one are astronomically small. Let's talk about what would happen if you were to take a tumble into a black hole. Spoiler alert, it's not a pleasant experience. As you approach the black hole, its gravitational pull would intensify, stretching your body in a process aptly named spaghettification. Imagine being pulled apart like taffy, your head and feet stretched in opposite directions by the immense tidal forces. Once you cross the event horizon, there's no turning back. The immense gravity would crush you into singularity, the infinitely dense point at the heart of the black hole. We've talked about spaghettification, but let's delve a little deeper into this rather unsettling phenomenon. As you approach a stellar mass black hole, the difference in gravitational pull between your head and your feet would become increasingly extreme. Imagine this: your feet, being closer to the black hole, would experience a much stronger gravitational force than your head. This difference in force, known as a tidal force, would stretch your body like a piece of chewing gum, hence the term spaghettification. The stretching wouldn't stop there. As you descend further into the black hole's gravitational well, the tidal forces would continue to increase, eventually ripping apart not just your body, but also the very molecules that make you, you. It's a rather gruesome thought, but it illustrates the incredible power of these cosmic objects. While spaghettification might seem like something out of a science fiction horror film, it's a very real consequence of getting too close to a black hole. Thankfully, as we mentioned earlier, the nearest known black hole is a safe distance away, so we can marvel at the concept of spaghettification from the comfort of our own planet. Chapter 4. Pocket-sized black holes. Black holes come in a variety of sizes, from the gargantuan supermassive black holes found at the centers of galaxies to the relatively diminutive stellar mass black holes. But did you know that there might be black holes out there small enough to fit in your pocket? These hypothetical objects, known as primordial black holes, are thought to have formed in the very early universe, just moments after the Big Bang. Unlike their larger counterparts, which form from the collapse of stars, primordial black holes are thought to have formed from the extreme densities and temperatures present in the early universe. While we haven't directly observed a primordial black hole yet, their existence is predicted by some cosmological models. If they do exist, these miniature black holes could be incredibly diverse in size, ranging from the mass of a mountain to the mass of an atom. Imagine a black hole the size of a coin, with the same mass as the Earth, lurking somewhere in the vastness of space. It's a mind-boggling concept, but one that highlights the incredible range of scales and phenomena that exist in our universe. Chapter 5. A glimpse into the abyss. In 2019, the Event Horizon Telescope captured the first ever image of a black hole. This achievement was the result of years of international collaboration and technological innovation. The black hole, located in the galaxy M87, has a mass 6.5 billion times that of our Sun. The image shows a bright ring of light around a dark central region, the black hole's shadow. This iconic image provided visual confirmation of black holes and valuable data to test Einstein's theory of general relativity. Chapter 6. The birth of a black hole. Black holes might seem like eternal, unchanging objects, but they have a beginning, a dramatic birth story that unfolds over millions of years. The most common type of black hole, stellar mass black holes, are born from the death throes of massive stars. Stars are cosmic furnaces, powered by nuclear fusion reactions in their cores. These reactions generate the energy that makes stars shine and counteracts the inward pull of gravity. However, even stars have a finite lifespan. When a star much more massive than our Sun exhausts its nuclear fuel, it can no longer support its own weight. The core collapses in on itself, triggering a supernova explosion, one of the most powerful events in the universe. If the core is massive enough, the collapse continues unabated, crushing the stellar remnant into an infinitely dense singularity, a black hole. These stellar corpses, remnants of once mighty stars, continue to lurk in the darkness, their immense gravity warping the fabric of space-time. The concept of black holes has captivated the human imagination for centuries, but it wasn't until the early 20th century that these enigmatic objects began to emerge from the realm of speculation into the realm of scientific inquiry. In 1915, Albert Einstein published his groundbreaking theory of general relativity, which revolutionized our understanding of gravity. Einstein's theory predicted that massive objects like stars warp the fabric of space-time, much like a bowling ball placed on a trampoline. Just a year later, in 1916, German physicist Karl Schwarzschild, while serving on the Russian front during World War I, found a solution to Einstein's equations that described the gravitational field of a point mass. This solution, now known as the Schwarzschild metric, predicted the existence of objects so dense that not even light could escape their gravitational pull black holes. Schwarzschild's discovery marked a turning point in our understanding of these cosmic objects, providing a theoretical framework for their existence and paving the way for decades of future research. Black holes, those cosmic vacuum cleaners, might seem invincible, capable of devouring anything that crosses their path. However, even these behemoths are not immune to the passage of time. While black holes don't technically die, they do slowly evaporate over incredibly long periods through a process known as Hawking radiation. In 1974, renowned physicist Stephen Hawking proposed that black holes are not entirely black after all. Due to quantum mechanical effects near the event horizon, pairs of virtual particles can be created, with one particle falling into the black hole and the other escaping into space. These escaping particles, known as Hawking radiation, carry away a tiny amount of the black hole's mass and energy. Over vast stretches of time, this slow leakage of energy causes the black hole to gradually shrink and eventually evaporate completely. However, the timescale for black hole evaporation is incredibly long, far longer than the current age of the universe. So while black holes might eventually fade away, their demise is a slow and gradual process that won't affect the cosmos for billions upon billions of years. Black holes and wormholes often get lumped together in science fiction, portrayed as cosmic shortcuts that allow for faster-than-light travel to distant corners of the universe. However, while both are fascinating theoretical objects, they are distinct entities with different properties. Wormholes, also known as Einstein-Rosen bridges, are hypothetical tunnels that connect two different points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That's a simplified analogy for a wormhole. While black holes are regions of intense gravity from which nothing can escape, wormholes, if they exist, could potentially allow for travel between different points in space-time, even across vast cosmic distances. However, wormholes are highly unstable and would require exotic matter with negative energy density to keep them open. So, while black holes might not be cosmic shortcuts, their existence raises intriguing questions about the nature of space-time and the possibility of other dimensions. Black holes come in a variety of sizes, from the stellar mass black holes formed from the collapse of massive stars to the supermassive black holes lurking at the centers of galaxies, millions to billions of times more massive than our Sun. Imagine an object so massive that it can warp the fabric of space-time around it, creating a gravitational pull so strong that not even light can escape. These cosmic giants, supermassive black holes, are thought to play a crucial role in the evolution of galaxies, influencing the formation of stars and shaping the large-scale structure of the cosmos. Their smaller counterparts, stellar mass black holes, are no less fascinating. These remnants of collapsed stars, scattered throughout galaxies, serve as a reminder of the cyclical nature of stellar evolution the birth, life, and death of stars. From the smallest stellar mass black holes to the most massive giants, these enigmatic objects continue to challenge our understanding of the universe, pushing the boundaries of physics and astronomy. So there you have it, 10 fascinating facts about black holes, those enigmatic objects that continue to captivate our imaginations. From their unimaginable density to their bizarre effects on space and time, black holes serve as a constant reminder of the vastness and mystery of the universe we inhabit. What was the most interesting fact about black holes for you? Comment below and hit that subscribe button not to miss more fascinating facts. Thanks for watching and see you next time.